Here's a wire made of iron. When you pass a strong electric current through it, the wire quickly heats up due to its resistance, glowing red hot until it eventually snaps and melts. But clever you, inspired by the glowing wire, wondered if a metal with an extremely high melting point could sustain that glow. So, you and your buddies got hold of tungsten, a metal with a melting point over 3000 degrees Celsius. Excitedly, you drew the tungsten into a wire, connected it to a circuit, and sure enough, it emitted a dazzling light. But soon, disaster struck. The tungsten wire broke again. The problem? The temperature of the wire, at just over 2000 degrees Celsius, was well below its melting point. Why did it break? Clever you quickly identified the culprit. Air. At high temperatures, the tungsten reacted with oxygen, forming tungsten oxide that volatilized, causing the wire to corrode and snap. What to do? Being the genius you are, you came up with a solution. Encase the tungsten wire in a glass bulb, evacuate the air to create a vacuum, and fill it with an inert, non-combustible gas. Success! The tungsten wire now glowed steadily and brightly when electrified, but the straight tungsten wire had too little resistance, and its light wasn't bright enough to illuminate the factory at night. So ingenious, you replaced it with a thinner, spiral-shaped tungsten wire. Its higher resistance and longer glowing section produced a brighter light. However, at the scorching 2500 degrees Celsius incandescent state, the tungsten wire became soft. No problem for brilliant you. You crafted a glass pillar, called a support stem, which was insulating, supported the spiral tungsten wire, and sealed the glass bulb to maintain an airtight environment. Congratulations, great inventor. You've created the incandescent lamp, allowing humanity to conquer darkness with electricity for the first time.